Thank you for joining us for another Hagley History Hangout. My name is Gregory Hargreaves, Program Officer in the Center for the History of Business, Technology, and Society at the Hagley Museum and Library in Wilmington, Delaware. Now, during these History Hangouts, we like to bring you some of the great research being done by folks using the historical collections at the Hagley Library, especially scholars who have received support from the Hagley Center. One such scholar joins me today. Kevin Moskowitz is a PhD candidate at the University of Texas at Arlington, and will be discussing his dissertation project titled Detroit Muscle, Automobile Manufacturing and the Middle West. Kevin, thanks for joining me.
Great to be here.
Wonderful. Let's start by painting with broad strokes. What is it you are researching and writing about?
Right. So my history is a history of manufacturing. So if you go to the, your Barnes and Nobles and you look at, the kind of car history section, a lot of it is dealing with sort of the culture of the automobile, your drive-ins and your, suburbanization and all sorts of great stories like that. But if you actually are interested in understanding how a car is built, there's basically only one form of history out there, and it's of the assembly plant. And there's been some great writing of these places where sort of everything comes together. If you have ever been to the Detroit Institute of Art and you've seen Diego Rivera's fantastic murals there, that's the kind of image that gets painted in these histories as well, as of this final assembly, all these parts coming together to form a singular car. And that's great. But the reality is that the automobile industry in North America is huge. And I think for some people, especially if you're my age or you grew up after the 1970s or so, it doesn't necessarily feel that way. But from the 1920s to the 1980s, the automobile industry was the single largest industry on the continent. And this is before you even consider the role of the oil and gas industry. Some people would throw that in there, but we're talking upwards of 20% of the people employed in the country are in some way connected to this industry. So absolutely massive. But it's not just, Ford Motor Company and General Motors. It's not just your Rouge River plants, that you can go on a tour of and see. It's thousands of companies all over the United States, but in particular across about a 600 square mile radius around the southeastern part of Michigan, basically. So what this dissertation project is designed to do is to take some of these larger considerations and look at the role of manufacturing and transportation networks, all of the things that needed to be developed and planned and refined over the course of 40 years. Basically, I go from about 1920 to the 60s, where things really start to change, arguably for the worst for at least the US automakers. And see how all of these improvements are made, how these decisions were reached, and what their consequences were.
Sounds like a supply chain history. Would that be an accurate way to describe it?
Yeah. That would be exactly sort of the way to look at it.
Well, could you perhaps flesh out what this automobile supply chain looks like? I suppose you're talking about this whole constellation of suppliers of parts and components that, as you say, then eventually get assembled in these assembly facilities.
Right. And to get some idea of this, Ford Motor Company, which is notorious in this period for really most of its history of being a very vertically integrated company, meaning that it controls and owns everything from the lumber that it gets from northern Michigan and the iron down to building the wheels themselves. As much as they can control, they want to control. However, even in the 1930s, they're using upwards of 6,000 independent companies. So, at the end of the day, they're going to some guys down the street in, Pontiac, Michigan, and they're saying, hey, we need you to build these radiators for us. Or in the case of what I've been writing based on the Hagley research, cylinder heads, we can't build these aluminum cylinder heads that need all of their own fancy equipment. So we're going to go to this company in Cleveland and we're going to have you guys build these for us. And the story of sort of how this all happens and what this means for all of these companies, particularly in an industry like the automobile industry that has really high highs and then really devastating lows on an almost cyclical basis, is a story that's really never been fleshed out, at least at sort of the level that I'm looking at.
Well, at least at this stage in your project, what is the narrative arc of your story from the 20s through perhaps the 1960s?
Right. So the the automaker that's really sort of the most pivotal and interesting in this story is Chrysler. A lot of times when you ask somebody sort of the who are the most important automakers, it's either, the Ford for mass production, for the assembly line, or it's Chevrolet for the model change and flexible production. But Chrysler is actually the first company, or at least Walter Chrysler is the first guy in this industry to go, all right, Ford and General Motors, they have all these plants that they have to manage, all these employees, they've got to have all of these research divisions to solve all these problems all the time. That's a lot of money. It's expensive. It's a lot of overhead. What if I built a car and I own nothing but the plant that puts all the parts together? And in 1925, the first Chrysler that rolls off the line is built exclusively on other people's equipment and other factories.
Wow.
There's not a single part in that car that comes out of Chrysler's single factory, which is the old Dodge plant in Hamtramck that they buy. This doesn't last very long. Eventually, Chrysler realizes, well, there are some things that would be good for us to build. But what's important is every single one of those parts is coming from somewhere in the Detroit area. Basically, they don't really have the communication structure and the transportation structure to make it cost effective to bring things from much farther than that. And there may be some exceptions. There's not a lot of great data or records from most of the automakers from this period. So we're largely having to make some guesses here. But from the information that is available, it seems like there's really not a whole lot of outside of this region. It's a very small network. But you fast forward even 5-10 years, as the automobile industry continues to build, even despite of the Great Depression, this bubble begins to get larger and larger and larger. In part, this is because of there's just practical limitations to building everything in a single place like Detroit. It's a boom town and it's largely a tent city. It grows so fast. But this means there's not enough heating oil. There's not enough power generation to actually handle all of the facilities there. And then you're dealing with a single basket of labor, which means when there is a labor problem, it affects everybody. So for all of these automakers, once it becomes clear that you can't really build everything in one place and you're starting to spread out more, it really makes sense to start to diversify these things, because you avoid, if there's a strike in Detroit, they may not necessarily spread, to Chicago or Cleveland or Pittsburgh.
And so then that's the story through the 1930s into the 40s. Then
basically,
do things continue to change, or I'm sorry, go ahead.
Yes, but like I said, the automobile industry is really cyclical. Like, it goes through these ups and then it has these extreme downs. But the same is true for the way in which the automakers think about the manufacturing process. You see this, you have this sort of same up and down of, all right, we're going to expand out to as many suppliers as we can, and then there's a tightening, and then Ford goes, okay, well, we're going to build another steel plant for ourselves because we have some insecurities about the changes, and it's sort of that ebb and flow over and over. Is sort of a constant, even through to relatively recently, although most of my research so far is to about 1945 or so. That second half I haven't done quite as much research into yet.
Okay. Well, how about the Hagley Library? What materials were you looking at there in order to uncover this story?
All right. So there's two main resources from the Hagley that I've been using. One is the American Iron and Steel Institute records, and this is largely a sort of a collected volume of publications of research files from the American Iron and Steel Institute, which was basically a lobbying group for iron and steel. And then the collection that I actually, when I went to the Hagley, didn't know existed, and I had an extra day left on my funding and my time, and I just was browsing through. I was like, oh, that seems related. I saw the word Ford in the description. I was like, all right, we'll give it a shot. It's this company called National Bronze and Aluminum Foundry Company of Cleveland, Ohio. And these records, and this will be an important thing a little bit later, go from about 1936 to 1941, and then 1945 to 1949. So you've got sort of two sections of papers, mostly financial documents, minutes from executive meetings, that sort of thing. But basically pre-World War II, post-World War II. And that's really basically allowed me to build an entire chapter focused around this aluminum foundry company and sort of the role of this single supplier in the manufacturing of this sort of really high tech at the time aluminum cylinder heads and other aluminum engine components, but also the pitfalls of being so reliant on an automaker for most of your work if you're a supplier like this, and what happens when you try to move away from that.
Well, why don't you unpack that a little further for us? So what products precisely was this company making in Cleveland? What automaker were they working for?
Right. So it's specifically talking about this first period, basically up to the Second World War. It's Packard, Willys Overland, Ford, and then Ford's Lincoln division are the main ones. The thing that really brings this company into sort of the automotive industry manufacturing forefront is Ford in 1932 introduces its very famous flathead V8, an enormous increase in performance over previous Ford engines, so much so that they used this engine into the 50s. But one of the things that Ford is facing is from all of these other automakers, you've got lots of new budget brands that are offering better value. Chrysler introduces DeSoto in the late 20s. You've got, of course, the Chevrolet brand, Cord. You've got a lot of these companies that are coming in and sort of doing what Ford used to be known to do. And one of the things that these companies are all fighting over, and it's sort of funny because it's one of the same, things now, is efficiency, right? They want to show that they have a very efficient automobile. If you're not spending a lot of money, you don't want to spend a lot of money, once you buy the car too. And what an aluminum engine does is it allows you to produce more power, which if you're trying to build a efficient engine, you want to be able to produce power without wasting fuel. And these are hypothetically more efficient engines. And in this period, recovering from the Great Depression, there is a demand for these, more efficient, affordable vehicles. And for National Bronze, which wins this contract, and who knows why they won it, but they have it. Again, the records I have only start in 36, 37, but they get this contract and they end up building not only cylinder heads, which is the solid piece of aluminum at the top of the engine with channels for fuel and air. And it's the advantage of aluminum here is that it can withstand really high pressures and high temperatures. Your valve covers, which sit atop the cylinder head and keep oil flowing and protect the engine from the elements. And then distributor housings, which regulate the electrical signals and spark plugs to the engine. So these are all parts that are sitting sort of on top of the engine. They're not the main engine block, but we're talking about 25, 30 pounds of aluminum per vehicle, which when you're building enough for hundreds of thousands of vehicles, because you have a contract with Ford, is millions of pounds of aluminum smelted every month in the best of months. And we're talking every single DC-3 aircraft that's built in the 30s, every single civilian DC-3, we're talking all of that aluminum in less than a month. So this is an enormous contract at the end of the day. However, the problem is you have these big ebbs and flows. So there are these great months, but then there are these really terrible months where Ford goes, we've overproduced, and now you have to sit and wait for the next model year for 2 or 3 years. And by the end of the 30s, Ford begins to move away from these aluminum cylinder heads. As the economy improves a little bit and as consumers are less choosy, it doesn't really make sense to be spending more money on aluminum than to have cast iron cast iron cylinder heads, which are the alternative to aluminum, and are much cheaper to build. They're heavier, but by the end of the 30s, it doesn't really seem worth it. And National Bronze is really only left with some Lincoln contracts, some much smaller ones. And when at some points in this period, they're 70% of the foundry's business, that creates a huge problem. And the foundry and its management, which by this period becomes almost a family company. This group of men, all with the last name Schmeller, who are German Americans who end up as the head of the company, vice president, treasurer, chief metallurgist, and head of manufacturing, or a head of the operations on the ground, are the ones that end up taking over. And they look into a lot of different avenues. They try to build escalator components. They try to move into the washing machine industry, but find that like unlike the automobile industry, that's extremely vertically integrated and it's
Mhm.
very difficult to get into. But what they really see as the cash cow is the airplane industry, right? Like if you look at any sort of media from the 30s dealing with aluminum, it's the aircraft that's the really sexy, exciting technology. Of course, the DC-3, which I mentioned, is like this really important visual object that kind of makes aluminum this very modern material.
Mhm.
And you have things like the Dymaxion car and the Stout Scarab, which are these sort of concept vehicles that are made of all aluminum, but they kind of look like airplanes because they're influenced by the airplane industry.
Mhm.
But of course, like the most successful commercial airplane of all time is still only using as much aluminum as 1 month of Ford production. So you have this challenge of, okay, well, we want to enter this industry, but there's just not as much volume. So
Mhm.
you have to be able to produce a product that you can sell for more money.
Mhm.
And this conveniently happens to converge at about the same time that the Second World War kicks into place. And because they have a contract with Packard, a much smaller one than Ford, but they are producing for Packard, Packard ends up selecting National Bronze for a contract to build Rolls-Royce superchargers for Merlin engines, which are what
Mhm.
go into like the Spitfire and then later into a lot of different bombers. It's a really important engine. They build millions of them. And National Bronze has the opportunity here to develop these supercharger housings, which would allow them to get into the door of the
Mhm.
airplane industry. They had made some contacts with the Air Force and NACA, which is the sort of nonprofit research arm promoting airplane research in the United States. But a lot of that sort of development is very expensive without necessarily having a guaranteed return. So these World War II contracts for these suppliers, and it's not just this company, but basically every level, gives a lot of these small guys the opportunity to get research dollars, the ability to learn new techniques, to acquire new equipment without having to actually spend for themselves.
Mhm.
Now, the really interesting thing happens, or the really interesting thing that happens here is going back to what I was talking about with the years I have available. I had 1937 to 1941, and then 1945 to 1949. There's these years missing in the middle. I thought that
Mhm.
was weird.
Mhm.
And you do some Googling of National Bronze and of the Schmeller family, and you find out this is the first and I believe only American company to ever be convicted of wartime sabotage.
Is that
It
right?
gets overturned.
Mhm.
Turns out maybe some of these charges, and I'll get to why I have some theories to why all of this happened.
Mhm. Mhm.
But it turns out these supercharger housings are not one of the big challenges with aluminum is welding. They're even
Mhm.
today.
Mhm.
Ford with the F-150, which is the first really mass market aluminum bodied vehicle, they've ended up having to rivet most of the parts together instead of using welding because the aluminum welding is very finicky, tricky, doesn't work
Yeah.
as well as it does with steel.
Mhm.
Um, and there's sort of a disagreement between the experts at Packard and the people at National Bronze as to whether these can be welded, what qualifies a safe weld on these. And the story that gets told in Time magazine of all places, this ends up in Time as under the title of like the most despicable acts, ... And then this scandal of allegedly National Bronze having the secret room where they're welding these defective supercharger housings, and they're only doing it at night, and they have a buzzer system. So like if people from Packard come, they know, or from the U.S. Army or Air Force, they can bolt up the doors and put things to hide all of the equipment. It's very scandalous sounding.
Mhm.
Um,
And elaborate.
and elaborate, yes. It really makes it seem like it's this conspiracy to build these horrible, poorly made engines that are going to kill airmen. Now, there doesn't seem to be, and on appeal, they make this point of like, well, none of them actually fail. They bring in experts from Ford who are also building similar castings for similar engines. They make this
Mhm.
point, well, the Packard people maybe were overreacting to this, and that they don't necessarily understand the way in which this works in the aluminum industry versus what they're used to in the steel industry. And this gets overturned. But what's really interesting to me is that this becomes this big case in the first place. And I have sort of two theories as to why this is.
Sure.
One is that in order to get aluminum in large quantities and new aluminum. It's important to note that even that in this period, there's basically two options. You either get your aluminum from Alcoa, the only new aluminum manufacturer in the US basically until the Second World War, or you can get scrap aluminum and you recycle it basically. However, the quality of the two is very different. It's very hard to produce a really high quality casting with only recycled aluminum. So it's really important to have access to that new stock. And the US stockpile, the only way war suppliers could get access to it is if they could prove they had adequate manpower. And this was a big problem for a lot of Cleveland plants, is that there was a considerable manpower shortage and an incredible race problem. Because there were plenty of African-American workers, but most of the Cleveland plants wouldn't hire them. And National Bronze was an exception to this. And one of the reasons National Bronze was able to get this contract of this scale and end up having to buy an extra building in order to have enough space to build these. It was an incredibly successful period for them up until the lawsuit, is that they were willing to hire African-American workers for roles that were traditionally only for white workers. So one of my theories here is that there's some animosity in the community for this, being able to get this contract of this scale, and doing so by hiring African-American workers, crossing that color line. Perhaps white workers at the plants are a little upset and, maybe more willing to tattle or are willing to shape things in a way that is unfavorable to the management. Because it's all management that gets indicted here. I don't know like actual line workers are in the charges. The other thing is that this family themselves that are basically running this company are all German Americans. The described in the Times piece, I believe he's a speckled and mustachioed man, the CEO, which are in the way in which it's written is not particularly flattering. There's which makes me think there's some like anti-German animosity in there as well. So those are sort of my indicators of why this ends up being this case.
So some combination of nativism, white supremacy, racism.
Yes, and ultimately why it ends up being overturned is it's not really as well founded as the Times reporters would like it to be. But after the war, this case really does a number. All of the Schmellers are also ejected from the company in this period. They end up forming their own company that outlasts National Bronze, although it goes out of business in the 70s. But after the war, National Bronze reputation really tarnished, is more or less committed to building aeromotive components. And they invest basically every dime they have into getting various certifications for these high strength aluminum alloys that are being used to build helicopter blades for prototype helicopters, for various propeller and engine components for aircraft. And they spend so much money trying to get this that they basically just run out, and the company folds in 49.
What is it about aluminum that makes it such a particular material? Why can't you run the same equipment handling steel and aluminum? What makes it particular?
So as a non-ferrous metal, and I'm not a metallurgist, and I've learned a lot more metallurgy than I ever thought I would learn as a historian. But a lot of the equipment that you use to mix this stuff can't be used for both ferrous and non-ferrous, and aluminum in particular is fairly sensitive. So you have to keep these things separate. It's why I think most of the automakers really never get involved in making their own aluminum components, is because it would require entirely new facilities that are separate. The pouring, especially for castings like this, and it's important to note there's a difference between the casting industry like this that are building these sort of parts out of molds, and then sheet aluminum, which is used for things like bodies or aircraft wings and that sort of thing, which all comes directly from Alcoa, gets sent to a finishing plant, a stamping plant, which the automakers do have. And because you're not melting the aluminum down, you don't have these sort of metallurgical concerns. But for the casting industry in particular, you need that separation. It's why it's National Bronze and aluminum, right? And not National Iron Smelting and aluminum. And most of these companies, there's another one called Bond Aluminum that's a Detroit company that I believe is originally Bond Bronze and aluminum. That's the one that invents the aluminum cylinder head for the automobile. But they all sort of, they are all start as non-ferrous, non-iron based smelters for that reason.
I see. That's fascinating. Now, would you consider national bronze and aluminum representative of this larger industry of automotive suppliers that you're researching?
Well, because of the whole treason thing, not really. Like, right? Like, there's this turn in the story that makes them extremely not exemplary of everybody else, but their experiences prior to the war do tend to truck with the other examples that I have, including from the Hagley. But one of the things that's really challenging, and one of the reasons why some of this has to be sort of accepted to some extent as a trend, is there are so few records of these middlemen, right? And the middlemen of manufacturing, these suppliers, just didn't leave a lot of records. I mean, the automakers didn't leave a lot of records, but we're really doing a lot of like almost forensic archaeology when we're getting down into it, because we're to some extent having to look at the individual parts. I mean, the dream for me would be to be able to take one of these cars from the 1930s that hasn't been touched and just blow it up, take every part out and put it down and look at, for the maker's marks on there to figure out where they all come from. Because really, if I didn't stumble across this, I'd have no way of knowing where these components would have come from otherwise, right? Like there's just no real database of any of this, which is a whole nother can of worms I don't want to get into. We just don't have the time. But that's the limitation of this. But I do think that at least the experience in the 1930s is largely analogous to other companies that are dealing with these automakers in this time. Both that we see these suppliers that are major suppliers, but they're no longer in just the Detroit area, that we have this geographic spread. Also, this sort of ebb and flow, the rise and fall of business, both within a year, but over multiple years. And that this can, especially for suppliers that are not used to the automotive industry, this can create a lot of problems and, of course, anxiety, a desire to innovate towards other industries and diversify, but also the pitfalls of that, right? That it's very expensive, and that the auto industry, because we're building on such a massive scale when we talk about these companies, a lot of the technological elements that go into making this stuff isn't as complicated as, say, in the aircraft industry, because it has to be built on such a scale. It has to be designed usually in a way that's more approachable. And it seems like the communication that these companies have with the actual manufacturers is not constant, but pretty regular. So they're not necessarily on their own, which means they don't have to necessarily have their own research departments. Again, we have one of the brothers of the CEO is running the metallurgic department here at this foundry, and is basically the entire research department, this one guy. So, there's only so much innovation this guy's going to do on his own. And like a lot of other companies in this period, if you're going to try to improve your product, make it more efficient, you either are buying patents and research from other companies, or you're getting it from the automaker themselves. And there's examples of both in this story.
Now, Kevin, I'm going to ask you to step out into speculative territory a little bit. Are there any implications of your work for the present moment, particularly as we're experiencing rolling crises across multiple supply chains across the global economy?
Right. Yeah. I mean, this is not even really the best example from the research of all the chapters that that really touches on this stuff. I mean, the story of aluminum, or of rubber in particular, is one where you could see a lot of parallels today. But one of the things that becomes very apparent, and not just in the shortages today, but in sort of general, bringing back manufacturing policy and rhetoric today. And one of the reasons why I think this research and this sort of approach is really important is the emphasis on assembly plants is still, to this day, an extremely provocative and powerful part of the way in which we look at manufacturing. And politicians we see on TV get very excited when they get an assembly plant in their district, or when they give massive tax breaks for this final point of the manufacturing process. But most of the people that worked most of the jobs in this industry were not assembling the final product. There's so many other steps that are all, still very important and bring in a lot of money to communities and provide a lot of opportunity and a lot of control in local communities, because a lot of these are small, local, family-owned businesses at the end of the day. So one of the things that I hope that people who end up reading the finished work take away from it is that when we talk about bringing manufacturing back to the United States, which I do think from a policy standpoint is a good idea, we need to think about all of the different ways in which we could bring manufacturing back, not just these very pretty assembly plants where you can stand in front of it with a finished car and take a nice picture. But we need to look at things like foundries, places that are producing all sorts of small subcomponents are really important to bring back. And it's one of the reasons why we have all the shortages now, is that just because we have, these big factories, assembly plants ready to go, if your weakest link is the one company that can't ship a product, then you're stuck with that one weakest link. And the more we can do to bring manufacturing back to the United States strengthens the manufacturing chain.
Well, Kevin, that's a really interesting point and such a fascinating story. Thank you for taking the time to speak with us today. It's really great.
Really glad to. I loved my time at the Hagley. I would tell anyone who's considering going, just do it. It's a really great place to do research.
Thank you for saying so. We do try our level best to facilitate that for folks. Now, for the audience, if you would like more Hagley History Hangouts, more information on the Center for the History of Business, Technology, and Society at the Hagley Museum and Library, join us online. You can visit hagley.org. That's HAGLEY.org. Don't be a stranger.